and in the program, in the abstract, it says diseases, pests and diseases. So just I use only pests, so that I hope it will cover the arthropods, the pathogens, and then a little bit of the parasitic weeds. This is quite a jump, a quantum jump from genetics to applied and field experiments and demonstration and others, because at the end of the day we have to protect the crops from arrays of pests to increase productivity, make farm profitable. If we are talking about farmers in Saskatchewan or in Southern Australia, but for countries where Ricardo is working, we are talking about securing their food, income, and their animal feed. So with this, I try to, because it's a broad subject, I try to put them together in a kind of framework so that we can have some discussions at the end. I will touch the cool season for legumes and their production constraints, the key pests we are working at ICARDA. Pest management practices, Jen just she put it there, and IPM technology transfer, because we have to transfer to small scale farmers. Pest evolution, I was a little bit hesitant to use the word evolution because I want to put some cases at the end, and then I said, okay, let me misuse this one, and then I put it that way. So I'll put some points at the end. So this one is, I'm trying to focus on fava bean, chickpea, lentil. Those are very important for different parts of North Africa, East Africa, West Asia, and South Asia. Because field pea diseases just are really presented very well. Like diseases like aphanomyces is studied to death, and really, I'm sorry for aphanomyces, but so everything is there. And then if you see why they grow, because they grow for food, they need them, for nutrition, they sell out of it, some of it to get income, and then they feed to their animals, and then they are very important also for their production system. If you see fava bean and lentil, these are the countries where we operate. If you see the acreage, it looks small, but the crops are very important. The acreage is low because of different biotic, abiotic factors, which I will come later on. If you take two examples, fava bean import in Morocco and fava bean import in Egypt, it is tremendous. Once the two countries were sufficient to fava bean means, we can call it a staple, full for Egyptians. It's a traditional food. And then if you take Bangladesh lentil, because of low production, and then the import is very high. If you take Algeria can compensate because they have resources. But countries like Bangladesh or my country, Ethiopia, importing is really a big burden. Let me take an example. What does a farmer use what he produces? Or what small-scale farmers in Ethiopia, they produce food legumes, for what purpose they use? If you see here, they produce 2.8 million tons in 1.6 million of hectares. They consume 58% of that, which is around 1.6 million. And then 14% they use it for sale, and then other purposes. Even they use part of it just for planting of the next season. Out of this, they produce 3.4 million tons of straw to feed their cattle. So they are very important for them. So the production constraints, there is a high yield gap or low productivity. Because of low yielding land races, so that can be handled by breeding. The biotic stresses are there. low adoption. There are a lot of breeding programs in many countries, but the adoption of those varieties or technologies is low. And then in some countries, these crops, the legumes, are given less priority by the government. For example, West Asia or North African countries. That leads to high imports and increased cereal monocropping. So, ICARDA, as a breeding center, we have divided the regions where we operate into a kind of mega environment where we send our germplasm. We have the South and North America, North Africa, West Asia, and then South Asia, Sub-Saharan Africa. Just I listed the major crops, the disease, sorry, and insects and weeds. So some of them have wide distribution. If you take Ascochyta blights, it's across. Some of them are region specific. So ICARDA is not trying to address all these arrays of these things, but we share with the national program, advanced institution, germplasm, and others. So with partners, we try to develop resistant materials through breeding, integrated crop management practices, and seed system and capacity development. If you see how many varieties are released from ICARDA bred materials or germplasm resources by different countries. We don't know whether they are complete resistance, partial resistance. And then we do also capacity buildings of NARS so that they can do a good crop development. And then through this also, we together with them, we train farmers. If they improve their knowledge, we change their attitude towards using modern technologies, and then they apply, and then they can manage pests properly. So I don't want to give this percent of losses, that percent of losses. Okay, the mission of CGR research is to ensure food security of small holder farmers. So if you cannot protect the crops or improve the productivity, we cannot assure food security. That means availability. Like production will be less, reserve will be less, economic or access to food will be affected, food utilization, the nutritive value. We're talking about nutrition, health, and all these things. That will be affected, especially micronutrient deficiency. Safety. The food safety for chickpea, faba bean, lentil is not a big concern. We don't have aflatoxin and all this. That one is a problem in groundnut. And I have seen one poster on cowpea. So this animal feed is also affected. Trade, if there are some quarantine pests, then the trade will be affected, as I said. And then, if there are new diseases, for example, I will come later, it will affect the genetic diversity. It will lead to genetic erosion. Look, this one is a rust in 1998 in Ethiopia. The whole lentil was devastated. Even the animals, they refused to eat the straw. And then if you see, this is a new faba bean gall. It comes in Ethiopia for the last 5 years, and then there is nothing. And then see, these are some of our improved varieties, and then these are local ones, these are two improved varieties. And then if you increase productivity, then storage is a problem. Look, these are beetles, maybe more beetles than the cereals, the grain. So what are the key pest management practices we use to manage? And then there are many reviews. I went, interesting reviews published. And then breeding for host resistance is the pillar of all. And then we have cultural practices, all kinds of them. And pesticides, seed treatment, foliar application, and then biopesticide, decision support system, whether that's applied to smallholder farmers, we will see later. And then I don't see this biofumigation is captured as one of the methods to be used for smallholders. And then finally, putting 2 or more of these through the IPM options. Then, when you come to developing host plant resistance, our breeders, they use cultivate cultigens, wild relatives. Although some resistances we have observed and being used by farmers, they have major genes. Most of them, either they are partial or we don't have available source of resistance. That's already available to farmers. And then these are some of the material. This is ascochyta screening. This is for chickpeas. This is lentil, and then this is for what? I think this is for lentil. And then I will try to summarize major genes, minor genes, so far reported, and there are a lot of unfilled columns or rows, cells rather, where they are not very available. So just I left them, and then this is germplasm resistant to leaf miner, and this is for fababin yellow necrotic virus, where they do some genetic material development. Then ICARDA's breeding program is also using locations like Syria, Morocco, Lebanon, Ethiopia, Sudan, and partner countries. So this is a very short summary, one example where we develop Kabuli chickpeas, and then we have spring and winter chickpea, and then this is where we screen for viruses, and then this is used to be our ascochyta applied screening nursery in Syria. It's not anymore there. This is a little seed plot we have in Lebanon, and this is a screening nursery we have in Ethiopia, where we don't have a single pathogen, we have a complex of it. So this is another, just to show you how our screenings are distributed. Since we don't have Staphylium blight, we do the screening together with Bangladesh National Program. And then we used to send materials from Syria or from here, from Morocco to Sudan. None of them were performing very well because they have a complex. So whatever we select in Ethiopia, and then it's becoming better because the pathogen complex in Ethiopia is more similar to Sudan. This is, I call it a menu. I tried to summarize. I told several times, and I said, okay, let's go like this. So we have all these are the small components. I put plus, plus, and minus, minus, and then I will explain with 1 or 2. Let me start with the easiest one. Rust. If we have resistant varieties like in India or Ethiopia, you don't have to worry about all these components. You just grow your high-yielding rust-resistant varieties. But if you don't have, then you can put either sowing bed adjustment if you have the slope to manipulate, or you can spray fungicide. If you go to ascochyta, you can use healthy seeds, but in small-scale farmers, when we are talking about healthy seeds, if they are produced by a company, he will treat the seeds with chemicals, and the price is very high. Then we have another option where we call it what we call it informal seed system, where farmers they grow, they don't treat it. So you can treat, or you can use other residue management. If you are a smallholder, he will not bury his straw. So, and then I put plus plus, 3 plus. That means if you have a good variety, you can grow, or you can put 2 or more affordable and effective IPM options. And then the other one is for insect pests. If you go for leaf miner, for example, either you manipulate your planting date, grow it, early spring or winter, then you will not have any problem. Or you spray. I'm talking about, for example, for the Moroccans, they spray. Or you can you adjust your planting, and then you can reduce the spray, and then you can. And then for brookhids, I think you have to have a different method. And then we also work on viruses. One virus, the Fabavin yellow necrotic virus, that put the Egyptian Fabavin acreage just down together with Orobanki. And then now we are also facing a problem of chickpea chlorotic dwarf virus in Sudan. So you can use, there is a package developed for this one, and the Egyptians are using it. But one of the recommendation is rogging, because the aphids, they land whenever they see scattered yellow plants. So if you recommend rogging, then it's very difficult. You destroy other healthy plants. So usually they use spray to control the vectors, and then they adjust the sowing date. In case of biofumigation, the Brassica crop contains glucosinolates. This is undesirable compound existing in the Brassica for oil crops. I think this is already managed. For example, in Canada, they have the 0 or very low glycosinolate. But countries like Ethiopia, where you grow the local Brassica, and then after it is extracted in the mill, we cannot feed it to the animals because it's toxic to animals. And then people start using it as a fertilizer. So if you include Brassica in the rotation system or as a green manure, you can contribute to reduce some diseases. For example, this is a simple preliminary trial done on Fusarium wilt in the pot. So this can be used in the management system. This is an example from my friend, from our entomologist Mustafa, where what he called it landscape ecology. And then people said, okay, I've heard yesterday that in Europe they have to leave 5% of their land for ecosystem services or other, because maybe they will get some compensation. But the small farmers, number one, they don't have enough land, or if they wish to do, nobody gives them compensation. So what he is encouraging is to use some medicinal plants or which have economical value that can attract some natural enemies so that they can be used part of the integrated pest management. So what about decision support? Can that be used for smallholder farmers? I borrowed this from a paper, by Rossi. And then, well, if you see here, there are areas where we can use practical decision support system that can be used for farmers. And then there are some stimpedia developed by Western Australia group for Staphylium blight on lentil. And then MAMTA is working just to use smartphones to do some prediction. So this can be also part of the pest management practices. Then I put that menu. What are the criteria for a smallholder farmer to select? And then I put from the top of my mind, okay, this could be more or some maybe not be applicable. The first one is it should be technically suitable of the option. If you ask him to intercrop based on our small trials, maybe it is not suitable for his farming practices. And then what about the knowledge or skill of the manager? In this case, the smallholder farmer is the manager. Then we have to show him, we have to train him, and then we have to improve his skills. For example, if you want to spray an insecticide against aphids on field pea or lentil, he has to know the aphid, and then he has to know the threshold. And then if he's equipped with that, then he can do the job. The synergy or complementarity of the options, they should be complementary. Effectiveness, they should be effective. For example, they prefer insecticides because the effect is quick than just developing a biocontrol agent using those plants. Then, okay, he has the skills and he knows it is effective. What next? You want to apply, for example, these things, certified seed pesticide and equipment. He should have the credit. Then he will ask this one. The other one is, if there is a target for organic production for export, then he will not accept certain components. So the way we do that one, there is some niche market for pulses, for example. Then when you work like a corda, just supported by a donor, sometimes they discourage one of the most important components in the IP. And then the other one is we have to think also the growth habit. If it is lodging, and then if the disease comes late, it's very difficult to cover the whole plant and do a good job to protect the crop. Then availability of inputs. Sometimes, okay, there will be small credits and all these things, or he can sell a cow or something, he has some cash. Okay. Then, are they available? Then these are some of the examples where we do in different countries using joint or bilateral projects for different pests. And then this is an IPM we have done in Ethiopia, where we can reduce the yield gap using these components. And then this is an integrated crop management in chickpea in Sudan, where we use these components. It's funded by IFAD and European Union. And then the CGIR started what they call it the system-wide program for IPM to the secretariat, and then bringing together all CG centers and other advanced institutions, but now it's no more funded. And